Okay, you've gotten through the background material. Now it's ready to you're ready to dive right into this student guide for the extrasolar planet lab activity. For the first two questions in the student guide, I encourage you to check out again the detection background page. Make sure you understand this graph, this radial velocity graph, as well as the little image that goes along with it. So what you have here is a star solar system. You got a star here, you got a planet here, and they're both orbiting a common center of mass. And you're viewing all this from off on the left side of the screen here somewhere. And what you're measuring then is the radial velocity. That means the velocity toward or away from the observer of this star. It's not the radial velocity of the planet. It's the radial velocity of the star. Now, the star wouldn't have radial velocity if it wasn't for the gravitational influence of the planet, but we're actually watching the radial velocity of the star. Is it coming toward the observer? Is it going away from the observer? If it's coming toward the observer, you wind up with a negative radial velocity. Toward the observer means negative. Notice the text here. Negative radial velocities is when the star is moving toward the Earth. That's a blue shift. A red shift is when you have your positive radial velocities. That's when the star is moving away from the detector or from the observer. Again, ignore this. That's an actual typo there. It should be saying moving away from the Earth there in the text. Okay, so that'll help you with the answers to questions 1 and 2 if you really understand that background page. Moving on. The third page in your background in your student guide really gets into the simulator. So you click on the exoplanet radial velocity simulator. And the first thing it asks you to do is to choose the preset. So go ahead and click on set option A for question 3. And notice what we've got here. We've got a planet going around a star, and we're viewing it from the Earth. Now you can actually change your views if you want. You can actually see kind of from the outside. Here's what it would look like from arrow 1, kind of from the side, because you would actually be looking at the planet blocking the sun. In that perspective, if you're looking as viewed from the Earth, in this case, you can see the sun or the star, and then the planet is off to the left side. And then the orbit view is if you're looking straight up and down. So choose your view, doesn't really matter. Question 3 has to do with this radial velocity curve, and the question is, what does it look like? What's the amplitude? Notice, what does this curve look like? And what is the amplitude? Meaning, if you're familiar with what an amplitude of a wave means, that means, see, looks like essentially like a sine wave to me. Amplitude is how tall or short the wave is. So if you essentially run a line from a horizontal line through the 0, notice you can measure the amplitude of this wave either by going from here and going down to see what's the bottom part, how deep is the bottom, or how high is the peak. These are called crests and troughs when you describe waves. The top is called a crest, the bottom is called a trough. The amplitude is from essentially the center, the middle, to either the trough or to the crest. So describe the amplitude, and then also describe the orbital period is what it's asking about. So notice that the system period is given over here. And all that really is just tells you how long does it take the planet or the star to go around their common center of mass. Now this depiction only shows the star moving, but in reality, it only shows the planet moving. In reality, both the star and the planet are moving around a common center of mass. So for the first few exercises, just kind of go through they tell you what to change and make those changes and then describe what's happening to that graph. Okay, I'm going to cut this one short. We'll describe the rest of the simulator as well as the other simulator, the transit simulator, in the next video.